Well, I thought I would talk about what's called neo-Darwinism, which sometimes comes in for some stick, and in particular, what can be called the gene's eye view, which is one particular way of looking at neo-Darwinism. The gene's eye view focuses on the level of genes, not specifically that they have to be DNA, although on this planet they are, but anywhere in the universe where there is self-replicating coded information which can exert some power, which we call phenotypic power, some power over the likelihood that it will be copied on into the future. So the key point about the gene, which is a somewhat abstract concept rather than having to be specifically DNA, for the reason I've just said, the key point about the gene in this model, in the gene's eye view of evolution, is that it is potentially immortal in the form of copies, because the copying of genes, I'll call them that, is exceedingly accurate, not totally accurate, but very, very accurate. There is the potential possibility that the information will last forever. And that opens up the possibility of competitive struggle between rival versions of these replicating pieces of coded information. Because although they potentially can last forever, not all of them do, and those that don't are selected away by natural selection. So that is natural selection. Natural selection is the differential survival of coded information which exerts power over its probability, over its likelihood, over its success in being copied, in being replicated. And the power that it exerts is phenotypic power, which means it exerts power over embryological processes, the building of bodies usually, although I would rather generalize that and say any kind of influence that a self-replicating entity can exert over the world, which improves its probability of replicating itself and passing itself on to the potentially eternal future. Any kind of influence that it can have will be favored by natural selection. The unsuccessful ones perish, the successful ones don't. The vehicle of their success or failure is phenotypes. It happens to be the case that in the forms of life that I'm most familiar with, which is animals, these phenotypes are great big vehicles. They're great big multicellular entities that move around as a unit, on legs or wings, or fins or tails. They are things that have eyes and brains and kidneys and hearts. That is a very special and in a way peculiar way of doing it. It didn't have to be like that. That happens to be the way it is. The more general way of looking at the gene's eye view of natural selection is to say that any kind of phenotypic power that can be exerted will be. Now, the gene's eye view has been criticized as being determinist, as though we are saying that genes exert a deterministic influence on bodies which is irreversible and inevitable and simplistic. And I want to really repudiate that most vigorously. I yield to no one in my admiration of the complexity of feedback loops, of the details, the immensely complicated details whereby genes actually do influence phenotypes. There's absolutely no suggestion that it's irrevocably deterministic. There's absolutely no suggestion that it's simple. But however complicated it is, the one thing that matters is that individual differences between genes are reflected in individual differences in phenotypes, and it is those individual differences in phenotypes that count as far as selection is concerned. So it doesn't matter how complicated the influence of genes on phenotypes is. It doesn't matter how complicated the feedback loops are. It doesn't matter how much involved they are with symbiotic ingestion of other types of organism. This can happen to your heart's content. All that matters is that differences between genes, differences between self-replicating coded pieces of information are reflected at the end of this amazingly complicated piece of embryological development differences between coded pieces of information are reflected in differences in survival of those coded pieces of information. And that's the important point. That's the only thing that singles out the gene in the hierarchy of life as being important in the gene's eye view. It's not that they exert a more important causal influence on bodies. The only thing that matters is that they are potentially immortal, and differences between individuals are reflected in differences in survival via phenotypic differences, which can be as complicated as you like, and which can indeed involve symbiotic relationships with other creatures. And here I come on, obviously, to Lynn's particular interest. Lynn, of course, is the great apostle of symbiogenesis. I don't think she goes far enough. What I want to say is that things like the incorporation of bacteria to be mitochondria and chloroplasts and possibly other things, they're just the tip of the iceberg. We can regard the entire gene pool of any species as a symbiotic collection of self-replicating coded pieces of information. The other genes in the gene pool should be regarded as part of the ecological environment of every gene in the gene pool. So every gene in the gene pool is surviving against a background of not only the external environment, not only the weather, the humidity, the rainfall, the predators, the parasites, the hosts, not only all of that, but also the other genes in the gene pool. And so the gene pool of, say, the lion species is one particular collection of symbiotic genes who are all cooperating with one another, with other members of the gene pool to make lions. And similarly, the buffalo gene pool and the kangaroo gene pool, they're all symbiotic collections of genes in just the same kind of way as Lynn has taught us with respect to symbiotic organisms. So in that sense, I think she hasn't gone far enough.